Welcome to today's tutorial. We'll be going through semester test to SSA, the 2022 revision, or the 2022 paper. So let's start. So the videos are gonna be quite long because I have to sort of explain in depth everything before I implement it, right? So the University of Johannesburg needs you to create a data structure called UJ-image, right? And you should name it exactly that, containing a dynamic two-dimensional array of structures representing pixels or picture elements. So that two-dimensional array should represent the pixels. So that means the two-dimensional array is supposed to be of type pixel, right? But is there such thing called type pixel? No, there's not. So we still have to define that pixel first. Then we use that type that we've defined inside the class. So a single pixel for a color image is defined as follows. So they're telling you a single pixel for a color image is defined as follows. So how do we know what data type, what data structure to use? So remember, we're gonna have two data structures here. So I'm gonna okay, let me clear my notepad and okay. So how do we know which data structure to use? So I'm just going to change this to C++. So how do we know which data structure to use? So I'll just talk about only two data structures. We have a class and we have a struct. So by data structure, what do they mean? What do they mean by data structure? Data structure, as written, as insinuated by the word data structure, it is trying to say that it's a way of structuring data, right? There's different ways of structuring data. The class, the way it structures data in terms of two things, right? You have data and you have methods. That's how it structures the data. You have data and the method. But by data, what do we mean? We mean variables, because variables store data. We use variables to store data. And then with the struct, we only put data or only variables. By methods, I just mean functions. Yeah, by methods, I just mean functions. So which data structure is applicable in our case? For a pixel, right? We're still focused on the pixel. So a single pixel for a color image is defined as follows. You see that we have red, which is an integer, which is which is data, which is a variable. And then an integer again, which is data, which is a variable. Then another data, another data. You see that we only have data for this type. So therefore, we're going to need to define the pixel type using a struct or a record structure. So with that being said, let's start. So let me open code blocks. Okay, it's loading. Okay, so there it is. So let me create a new project, console application, C++, and then this will be computer science 1B, semester test to SSA 2022. Then I'm going to open my manager and then I'm going to open this. So before we do that, I think we might have to set up our, let's set up our project, right? Remember, we're gonna need files. So you see, they told you here, you also have been provided with the following in order to assist you in developing the system to the UJ standards. So we need to download these files and make use of them within our project. I'm not going to touch the DLL section because I don't think you should, that's the bonus you should be attempting. Attempt templates or exception handling, one of those. So they say if you want to test your output exactly like exactly like the shown question, like exactly on the shown on the question paper, you can download the circles underscore largest. So I want to show it exactly like this. So I'm gonna download the largest file. So I'm gonna download it. Okay, why is it? Okay, it was just taking its time. Yeah, I chose this past paper because now I can actually have the files. So the files that I need are the circles largest, download that file, continue download only, and that main.cpp file. So I'm gonna close that, and then the download should start. So there's the download. So I'm gonna close this, and then I'm gonna go to downloads folder. So this is how you're going to add the files. Then you select or cut those two files, and then go to where you've saved your project. Remember, you're gonna have to save it on T drive, so that when the computer switches off and then or it jams and then they tell you to restart, you still be able to find your work. And then I'm gonna press Control V to paste here. It's gonna tell you that main.cpp already exists. You don't say skip this file, because if you skip this file, that means you're gonna remain with this same main. So I do not want that. I want to replace it. So replace the file and the destination. Then when you go back inside code blocks, it's gonna tell you, wait, you've modified main.cpp. What should happen? Should I reload it? Yes, you should click yes because you want to reload. So yes, and then there's everything. So you see, this is, and this file is important. Why? Because you get to see what your methods should be called. For example, this is how you should call your method that's going to read from a text file. And this is how you should call your method that's going to write to a text file. So keep that in mind. So I'm going to create a new file. And as you can see, they're expecting you to have a ujimage.h exactly like that. So you should name it exactly like that. So I'm going to create a header file, ujimage.h. I should name it exactly the way they've named it, or else my code is not going to run. And then select all because I want to be able to debug and release this code. And then there's my header file. And then since we're starting with UJ, I'm going to implement a majority of the work inside UJ before I define other classes or other header files or other files. Then I'm going to say new file. For the bonus, we will do the bonus separate. So what I'll do is I'll just code everything. It's up to you whether, but the thing is, the way you should submit the bonus, right? The way they expect you to do the bonus, you must write the code first, the normal code, and make sure everything compiles. Then you upload that. Then you create a separate file and a separate project, or you just change the one that you have because you would have already submitted that other project, right? Then you just change this one. So you change every single, okay, not every single one. You change UJ to .cpp, something to .imp, I mean. Every .cpp change it to .imp, and then yeah, you change everything. I'll show you how to do that. So ujimage.cpp, and then select all, and then finish. And then here I'm going to say hash include uj image, right? Uj image, and then let's go back to our structure. So they said a single pixel. So that means I'm going to name my record structure pixel, or UJ pixel, or RGB pixel. It should make sense. So I can name it RGB pixel, so that in the future when I look at my code, I'm like, oh, this and it's not enough to say it's a pixel, because there's a grayscale pixel, meaning a P2 image. So there's many different types of image. There's a P1 image also. So I have to specify and say that's an RGB. For my case, it doesn't really matter, but for your case and the person reading your code, they should be able to understand what was your intention. This represents a single RGB pixel. And then let's see what's the pixel. So they said it should be an integer in the range 200, 0 to 255. So you see, they told you the range, right? They told you the range. So I'm not going to, and it's supposed to be a positive number. I'm not going to use, okay, you could use the normal int, but then the thing is, I do not want to accept, yeah, I'll just use unsigned. So you see, that's a very small number. If there was a byte type inside C++, we would use that. Okay, you can use it, right? There's this thing called you see this thing called embedded systems, right? So you could say int like this, an 8-bit integer. You could create it, right? And say int 8 like this. So what this means, it means that this is an 8-bit integer, meaning that it can range from it will range from minus 128 to 127. But we do not want the negative portion of it. We want the unsigned version. How do you get the unsigned? You're going to say uint 8. You're going to say uint 8 underscore t. So this would be the 100% correct way of doing it, and you're also saving memory. But for the sake of not confusing you guys, let's just use the unsigned short. So unsigned short, this would be my red color component, and then unsigned short, my green color component, and then unsigned short, my blue color component. Why did I pick a record structure? Because remember, record structure, it's a way to store multiple variables of different types. Remember, with an array, you can only store values of the same type. With the record structure, you can store variables of different types. And then probability. Yeah, we need to have a probability, an integer denoting the probability of the pixel being visible. So we need an integer. Okay, they said it's an integer. So I'm going to use unsigned short again. Unsigned short probability. And then there's your record structure. So let's see. Yeah, we'll do everything as we go, because there's also alignment padding, right? Here where they talk about alignment padding. Okay, yeah, okay, see, see how important it is to read instructions. If you look at T5, what does it tell you? It says define UJ color structure. So I need to call it UJ color. So yeah, normalize going to that bottom section and reading what it says. So it's going to be UJ color, and we need to add alignment padding. Okay, we need to make sure that the alignment padding is disabled. So we go back up. So we've created the record structure. As for UJ image, we're not sure because they said you should create a data structure called UJ image. That is a two-dimensional array of structures. So we're not sure whether UJ image is going to be another record structure or a class. So we need to continue downwards and get confirmation. So if you continue downwards, right, they tell you that class basics, you must create a class to represent the UJ image. So now I know, oh, okay, I need to create a class. It's not a record structure. So this will be UJ image class. So I'm going to say class UJ image, right? So UJ image, and then let me okay, UJ image. So the class must make use of principles of good design known to you. It must additionally make use of the two-dimensional array of structures. So they're just telling you use principles of good design that are known to you, meaning whether we need to have record structure, what is this, copy constructor, no args constructor, parameterized constructor, all those things. So I'm going to create my constructors, right? So I will put all of them. So before I create the constructor, let me add the array. So UJ color pointer underscore pixels. And then remember those pixels, they need to have a size, right? So I need to store the size. So I need to store the rows and columns. So unsigned short underscore rows underscore calls. And then I have those rows and columns. And then I'm going to create a no args constructor. Then I'm going to create a parameterized constructor, which is going to take in two things, unsigned short, which represents the number of rows, and then unsigned short, which represents the number of columns. And then I'm going to have a third constructor that's fully parameterized. That is all three. The It has the rows and columns, and it also has the UJ color that we must initialize it to. So there we go. So this is how I'm going to structure it. I'm going to have three constructors, one with no args, the second one with parameters, but only the size of the image. And then the third one is the fully parameterized one, the one with all the requirements from the user. Remember, the constructors are builders, right? They're meant to build the object. So I'm giving the user a plethora of options to build the object from. So they can build the object with the no args constructor, meaning that they do not have to worry about how big the image should be and what should the default color of the image should be. They do not have to worry about that. Then the second one, it takes in the rows and the columns. So they must provide the rows and the columns, how big the image should be if they have a specific requirement. And then the third one, it's when the user wants you wants a very specific image. So it needs to be of a specific size, meaning rows and columns, and it needs to have a specific default color. So imagine these are just different types of builders. For example, when you're building a house. So this no args constructor, it's like that builder who doesn't get information from their client. So they don't care how you want the house to be. They come up with their own values. So hence we're going to use default values or constants. And then UJ image with two parameters is the type of builder who just asks you, how big do you want the house to be? But the rest of the things like the color and whether they should have a fitted in furniture or whatever, they will decide those parts. But the size of the house should be decided by you. And then the third type of builder or constructor is the one who takes in the number of rows in the columns, which means the size of the house. In this case, we are dealing with an image, so the size of the image. And what color should that house be? Oh, I want the interior to be a dark purple or whatever, and then I want the exterior to be indigo or whatever the requirements are. This third constructor takes all of them. And then the third constructor, or third type of builder, is the lazy builder. It doesn't do anything creative. It just copies his neighbor. He sees another build, it's like, oh, so this is what you've built, let me copy it. So it's like, for example, when you go inside the library, right, and then you make a copy, you print, right, you make a copy of a document. So this is what this builder does. It sort of does that. It just copies what someone else has already created. So if I'm copying what someone else has already created, that means I need to take in a UJ image. But then if I take in the UJ image as it is by value, it's going to be too big, right? I might not have the capacity to take in the whole image by value. So I'll take it by address. So that means I'll go to where that image is located instead of me receiving the full image in my hands. So for example, you wanted to make a copy of a car, and then they lift the car up with those machines, then they put it in your hands like, okay, there's the car. Would you be able to hold it in your hands? Nope, because it would be too big. You wouldn't have the capacity to hold that car. So hence you'd rather get given an address, you go to where that car is located, and then you just look at it at that specific address. The address could be something simple, like it's in the garage, right? That's an address. It's in the garage. You just open the garage, you look at it whilst it's in the garage, then you draw, right? You make a copy, and then once have a drawing, you go manufacture that exact same car. So you see, it was way easier and way convenient to go to the address than to get the actual car. So that's why we typically take things by address. So but then the thing is, if you take it by address, you might have the ability to make permanent changes. So if someone tells you, okay, go to my car, it's in the garage, then they ask you, where's the garage? Where's your house? Then someone gives you the address. That means you can go to their house and then bend their car. So that would be what we call permanent changes, right? So when the owner comes back, they'll see the car is bending or the house is now everything has been bent to a crisp, right? That means that they have the ability to make permanent changes. So we need to prevent that. We need to put a const there, const keyword. By const, it's like a safety check or safety net to be like, okay, we know that you have the ability to make permanent changes, but there should be something that prevents you from making those permanent changes. For example, you go to that person's house. When you go to that person's house, maybe you as the owner, you hire a security guard, and then the security guard, wherever you are in the house, he's following you around. So that's like a safety check to make sure that you do not change or you don't touch anything. So that's this const, that's what he's doing there. And then since we have everything, so now I need to say these are my constructors. And then this will be my destructor. So since we have builders who are able to build the object, we must have people who are able to destruct or destroy the object. So I'm gonna have to create a destructor, which will destroy the object when it's no longer in use. For example, the owner of the house has passed away that was built, right? So obviously, in order for the government or whatever to build something on that land, they'd have to demolish or destroy that house. So we always have this destroyer just in place when we need to destroy that object that we've built. And then I'm gonna create my class constants, right? So class constants. So to create a constant, right, you 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 normally declare the variable the way you want to declare it. So for example, unsigned short, and then the way you name constants uppercase letters, and then each consecutive word is you separate each consecutive words or the words by an underscore. So what do I mean? So if you say default rows, right? You see these are two words. Default is its own word, rows is its own word. So I need to separate them with an underscore so that it's easy to read. As you can see, now it's easier to read. And then I'm going to initialize that to, let's say default rows, the image should be 800 by 800, right? And I'm using curly braces, which is exactly the same thing as me doing this. There's many ways to go about doing it. So I'm just going to use curly braces. And then I have my default rows. And then unsigned short default columns, which is the same. I'm going to put in the same size, 800. And then unsigned short default pixel. So what will be the default pixel? So you see now there's going to be quite a huge difference, right? For default pixel, you see that okay, I shouldn't say unsigned short, my bad. It's UJ color. UJ color. The pixel is of type UJ color. So if you notice something, UJ color it has how many variables or how many information? 4. So within the curly brace, that's when I provide 4 values. So so let's just make it a white image. So 255, 255, and then the probability, let's just say 1. Just put in a random value 1. So we've defined our constants, right? But then we are not finished. So when you leave it like this, it's what we call a variable. So when you declare it like this, and you just specify the type and name, and you say it's equals to some value. So for example, int x is equals to 10. This is what we now call a variable. Why variable? Variable because it varies. The keyword is it varies. By varies, it means that it's just a synonym or fancy way of saying it changes. That's what you mean by variable. So since it varies or it changes, that's not what you want, right? How do you prevent it from changing? Because remember, it's a constant value. It's like pi. Does pi change? Nope. Pi is a constant. So you just put the const keyword. So there's two types of keywords. There's the const, then there's the const expression, right? So the const keyword, you use it only when you have integers or single values. By single values, I mean integers. If you look at an integer, 10 is just 10, right? But then if you look at numbers like a double, it's actually multiple values and the special symbol. So technically it's not really one value. So const expression is the opposite when you have multiple values. So by multiple values, this could be in order for you to see it clearly, for example, a record structure. It has multiple values, but also with a double or a float, you should use const expression. Why double or float? Like I said, if you look at a double, we have the quotient, right? Let's say 10, that's the quotient. And then we also have the remainder, let's say 5. But then these numbers are divided by a dot. You see, there's that dot there. So you can see that there's multiple values here, multiple characters. I have 10, which is one or the first thing, and then character 2, that's the second thing. 5 is a remainder, which is 3. So I have 3 things. So you see, like I said, you only use this when you have integers or single values. Here I have multiple values. I have 10 and I have a 5. So you have to tell C++ that it's actually a const expression. So const for unsigned because it's just one value. Const. And then for UJ color, since you see that there's multiple values. So I'm going to use const expression. And it's going to shout at you and tell you that you can use const on what to add multiple values. So you have to use const expression. So this is fine, right? But then you see that these values are constant. They shouldn't change. I shouldn't create, I shouldn't waste memory and say every single object has their own copy. So by their own copy, let me just explain it like this. So by their own copy, it means that if you have UJ image obj1 and then you have UJ image obj2, it means as obj1 has its own copy here, and then obj2 has its also its own copy. But why should we do that when clearly these are constant values? They do not change for any of the objects. So since they do not change for any of the objects, I shouldn't continuously allocate memory for every single object. What I should do is I should make them share the same memory, right? The same variables to save memory. So by sharing, what do I mean? It's like, for example, you and your friends have you and your friend and your bestie, whatever, you went to a shop and you wanted to buy, let's say, a hoodie, right? So imagine, let's just say for for this example's sake, both of you have the same body frame. So that means whatever can fit on you can also fit on your friend. So you could there is actually no point in buying two hoodies and it's the exact same hoodie. You see that you're wasting money in that scenario. So think of that as wasting money. In C++, we say that you're wasting memory or space. So instead of you guys buying two hoodies, each person has their own hoodie, and it's the exact same hoodie. You can all tell C++ to be like, okay, make them share that, make both of them buy exactly one hoodie, then they share that one hoodie. So today, um, if today, your friend wants to go to a date or whatever, they have to have the hoodie, right? They put it on. And then on another day, when you have a special event, maybe you have a family gathering, whatever, then you ask your friend to give you the hoodie, then your friend gives you the hoodie. So you see, you're sharing, you're saving. So if the hoodie was 1.2, and yes, that means you guys were supposed to say spend 1.2 each, and then you spend 1.2 on one hoodie, that means you have saved 1.2. Then that 1.2 that you guys have saved, you can just split it up, go 50-50. You give your friend 600, and then you take 600, then you buy something else. So that's the concept of static, of sharing that information, sharing memory. So I'm gonna put static keyword here to say that it should be shared. Don't create don't create its own copy for every single object because it's the exact same thing. So static const and then static const expression. So yeah, I that static keyword is very important, saves memory. So now I have my what is this? I have my constants, I've defined them. So now I need to define my accessors, right? So I need to define my accessors because we might need to access the rows and columns. I'm pretty sure you have to. Yeah. So I'm gonna have unsigned short get rows. It returns an unsigned short. Why? Because the rows are of type unsigned short. And then this function is only meant to access. So I'm gonna put a comment here that says only access. There's nothing else that you should do. You should only access. So if you should only access, I can put in the keyword const at the end there to say that whatever code that will be written within this function should not change any of these things. Whether it's the rows, whether it's the column, it should not change anything. It's only meant to return or access. And then I do the same thing for get calls to get my columns and then const. So I've appended the const. And then now let's see. Yeah, let's look at the operator overloading. I want to see if we're going to overload the indexing operator. So overload the negation, overload yeah. So we do not overload the indexing. So I need to create an accessor to get the pixel. Because remember, within if I had overloaded the indexing operator or I was asked to overload, then what I could do is I could just say obj image like this and say pass in the row and column, and then dot red to get the red color component. But in this case, they didn't. So what I'm going to do is I'm going to create a function to get the UJ color. So UJ color dot get color, and then const because it's only meant to get the color. And then it should take in the row, which is going to be answer in short, and the column of which that pixel is stored. Remember, the UJ color is in a 2D, it's a 2D array. Basically, it's in a 2D plane or Cartesian plane. Remember the Cartesian plane, you need to specify the X and Y value to go to the specific coordinate or that specific point. The same applies here. You have to specify a row and a column to go to that specific coordinate. So hence, when I get the color, I pass in the row and column. And remember what I told you, inside the header file, you do not need to say this is rows, whatever. You do not need to name your parameters because this is the header file. Its main point is just to declare to make things available. So that's enough information for it to know, okay, you should take in an answer in short. When you go to the CPP file, that's when you give your parameters names. So I created that. So let me see. The thing is, I have to read. That's why I'm reading and checking what's supposed to happen exactly. So let me see if I'm supposed to change the images. So if I'm supposed to change the image, since I do not have an indexing of an overloaded indexing operator, I might need to create a set pixel function. So the UJ record structure representing that must be drawn to the image, or an inner radius representing the smaller what all values must be set via, and then color splasher, noise splasher, override special to perform. Okay, I need to check at the top how the formula works. A pixel within the two radius must be drawn with 100% probability. A pixel that falls within the larger of the two radii must be drawn within the probability it's assigned to. For each generated pixel, a solid circle must be drawn into the image. Only one of the two radii. Okay, so you see that we are actually changing the pixel. So we are drawing. So I need to actually create a mutator. So mutator. So its only purpose is to only mutate. Yeah, it's only to mutate or change, right? Or change. And then since it's only meant to mutate, so it's going to return void, meaning nothing. And then I'm gonna call it set color, which takes in three things. The specific coordinates, which is the row and column, and the value that I want to set that specific point in my 2D image, which is the color. I want to set it to the specific UJ color. And then, yeah, that's pretty much all we need. You could, but the thing is, I don't want to teach you like very advanced things, but I'll just leave it like this. But that you could technically save memory and pass all of them by constant reference. You could do that, but I'm not gonna sort of make my code look complicated since you guys are still beginners. Da, 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 da. Okay, so let me see. Yeah, I think I'm pretty much done with the UJ image class. I'm just like lacking a few things. So we've made use good principle design that are known to us. We've made use of that. So I need to scroll down and see something. So before I do this part, I need to scroll down. I need to see the T4. T4 talks about the operator overloading, right? So an overloaded assignment operator which performs a deep copy. So one thing I'm gonna tell you, right, which is free advice, assignment operator is always there. And copy constructor must always be there. and destructor must always be there. To call that, I think I call it the big three. So I'm going to say overloaded operators. And then remember, I need to overload, I need to use the operator keyword, right? Followed by the actual operator. What's the operator that I want to overload? I want to overload the assignment, which is the equals to operator. We should take in what? A UJ image. So it should take in a UJ image, but remember what we talked about. To save memory, we shouldn't take it by value. We should go to its address. But when you go to its address, we have the ability to change that object permanently. So since we are just assigning, we need to prevent that. So I'm going to put a const. And then we need to be able to return that image, right? But that image, when it's returned, we need to return it by address to save memory. But it's up to us, right? I don't know whether after you've reassigned or after you've assigned the object, you can assign it again. So I'm just gonna put const because I was not told whether I should reassign the object again. So what do I mean by reassign? So what I mean is, for example, you have UJ image, obj1, obj2, obj3, right? You have all those UJ image objects. So let's say I want to copy from obj2 into obj1. So what I was saying is, I'm not sure if this is allowed to be able to copy from in this order. So it starts at object 3, copy it into object 2, and then take the value inside object 2, copy it inside object 1. So in order for that to work, right, you need to remove the const. So that's why I'm saying I'm not sure if this is what they want, but they didn't specify. So let's just read, but I don't think they did specify. And overload the assignment operator that, yeah, they didn't really specify. Or you can just check in your main how they use that assignment operator. See, they did it this way, but they did specify here, like in that order, but you see that they didn't actually use it. They didn't say obj1 is equals to obj okay, they didn't say obj1 is equals to obj2, which is equals to obj3. They didn't do it in that way. If they had done it in that way, then we shouldn't return, we should remove that const. But the way I think I'm just going to remove the const because you see the way they put the comment here, they mean it should be working in that, it should work in that sense. So let me just remove the const and just return it by address like this. So I have overloaded the assignment operator. And then what's the other operator? Support for stream operator for output. So that's stream insertion. So remember, friend functions that are supposed to be at the top before any access modifier, before any public or private or protected keyword, at the top, at the very top. So I'm going to say friend, but since I'm going to make use of the IO stream, I need to include it. So hash include IO stream, right? And then I won't say using standard namespace. And then we know that it should return an O stream reference. And then the operator is the stream insertion, which is two less than symbols. And then you take in two parameters. Why two parameters? Because remember what I talked about. Remember when you say cout, when you say cout obj image, right? What is on the left-hand side? It's an OStream object. Cout is of type OStream. And then what is on the right-hand side? It's of type UJ image, right? So that's why it needs to be in that exact same order. So you need to say standard OStream by reference, comma. Since I just only want to output, I want the UJ image, right? I only want to output it, so I need to go to its address, but I only want to output, I need to append the const there, right next to UJ image. And then I'm going to delete this. So now there's your friend function. Then now I can go back. So support for the negation operator. So they say support for negation, right? So that means you should be able to negate and then negate that object. So this will loop through the array and sets all the red, green, and color components and of every pixel to 0. The probabilities must be left as is. So keep that in mind. The probability, you must leave it as it is. Don't touch it. So let's continue overloading our operator. So you see that it doesn't return anything, right? You see this function doesn't, they say you should use it this way. It's not returning anything. So I can safely use void. So I'm gonna say void, and then the operator is what? This operator. And then yeah, I can safely do it like that. Yeah, so this operator, yeah, I think I can do it like this. I don't know whether I should take, if you're taking an UJ image, nah, I'll leave it like this. And remember, any function, there's two ways you can implement an operator: as a member function or as a non-member. So technically, if you wanted to, you could implement it like this and say friend void, but then you'd have to pass an UJ image here because it's a non-member. So I'm just going to implement it as a member function and leave it like that. And then that's pretty much all we have to do. So let me add the alignment padding. Let me see how far. Okay, we the time is still okay. So define okay, so okay, let me go back to T2. So the UJ image class has a color splasher. So I need to create the color splasher first. So let me create that class. For now, I'll just make it an empty class. So color splasher.h, and then save into my project folder, remove the underscore included. And then I'm going to say class color splasher, right? Just an empty class for now. And then I'm going to create its equivalent implementation file, and then save it into my project. Click off, finish. And then at the end of the day, I need to include its header file .h. Then go back to UJ image. So remember what we talked about when you're inside here, right? You are still declaring. There's no need for you to include the header files because header files includes the whole class implementation. We do not need that in the header in the UJ image header file. We only need to know that color space is some type. It's something, right? So we just only do a for declaration. So the UJ image class has a color splasher. So this is what we call containment, right? Meaning one thing is contained within the other. So for example, a car has an engine. So the engine is contained within the car. So there's two different types of containment. We have aggregation, where there's no life cycle dependence, meaning that whoever has that object is not responsible for managing its life cycle or managing its existence. So for example, it's like you being in a relationship. You being in a relationship, it doesn't mean there's no life cycle dependency there. You can live properly, you can live fine without your partner. They are not your oxygen. But then when it comes to your relationship and oxygen, we call that composition because there is a life cycle dependence. You cannot live without oxygen. So you depend on the oxygen. So that's life cycle dependence. So with that being said, let's see what type of containment this is. So which implements the splash method, right? So and the UJ image needs to have that same splash method because remember we need to be able to delegate. To delegate just means, you see, there's that delegate. We need to, by delegate, it means that, okay, I know that I'm supposed to do this, but I'm going to run away from my responsibility and ask someone to take over. Whereas I should be the one who's responsible for that. But then I'm just gonna run away and be like, okay, I'm not going to be responsible for this. I'll just ask someone to do it on my behalf. So that's pretty much what delegation is. So which implements the splash non-value returning. And they gave you so many hints. They told you what is the what should return, meaning nothing, and they even told you what keyword to use. So I don't understand how you can fail to declare this function. So I'm going to create the function here, void splash, and it's meant to change. So I'm not going to put the const at the end because it's meant to change the UJ image. So the non-value that will set the pixel attributes of the UJ image. So let's read this properly, right? Like Cyril once said, oh no, not Cyril, Zuma. I was like, listen properly, listen properly. So yeah, listen properly. Set the pixel attributes of the image. This point that I highlighted here, I'm gonna come back to it. This is very important to know how to declare the splash method within the color splash. The UJ image delegates its own splash method contained to the contained color splash. So I did the UJ delegates. So it needs to delegate. But remember, before I do that, let me create color splasher. So I'm gonna go over here. Let me put it here. Go over here and then underscore splasher, right? And then this is containment, meaning that color splasher is contained within the UJ image class. But what type of containment? So we need to know whether UJ image manages its life cycle or not. If it does manage, that means we need to make it a pointer because we're going to allocate the memory using the new keyword. So the UJ image class must manage the life cycle of the color. Splasher must manage. So like I said, now it's composition. So we need to put in the pointer, the composition. So obviously it's gonna complain that I don't know what color splasher is. So do a forward declaration. So do a forward declaration to just say I promise color splasher is a class. Just that's the only information it needs to know at this point in time. That's enough information. And then modify the previously created classes to use an inheritance hierarchy with polymorphism as follows. Yeah, blah, blah, blah. So before we do that, I know that color splasher needs to have that splash method, right? Because how can we delegate um, the splash method to the splash method of color splasher unless we define the method inside color splasher? So we need to define it inside color splasher. So I'm going to come inside color splasher and then define that exact same method. So void splash, right? But then remember what the color splasher should do. This is very important. Color splasher should what? Should set the pixels attribute or pixel attributes of UJ image. So it should set the pixel attributes. So it's changing UJ image. So it needs to take in a UJ image, right? It needs to take in a UJ image, but it needs to take in UJ image by address, right? But then we do not want to change UJ image to point to a different image, right? So I'm going to put in the const. Remember, you can still call methods to change the pixel, but without changing UJ image. So by putting this const here, what do I mean by const? It means that once I have a UJ image, let's say obj1, I cannot do this. I cannot say obj1 is equals to obj2. This wouldn't be allowed. See over here, it wouldn't be allowed. So that's why I'm putting the const there because I do not want either way. I do not want to set it to a different image. I'm only working with that image, so I'm gonna leave it as const reference. So the UJ image delegates its own splash. Yeah, we'll delegate that once we're there. And then the splasher is okay, so what I would do, right? I'll just create the different classes, all of them. And then in the next session, in the next video or the next part, we'll continue implementing, starting with UJ image. So let's read continuously and find out what's going on. So they said color splasher is an abstract base class. So what makes a class abstract? So a class, an abstract base class, right? Abstract, abstract base class is abstract is another word for incomplete base class. That's what abstract actually means there. So what would make something incomplete? Before we can find out whether how to make something incomplete, we need to understand how to make something overridable, right? The keyword is overridable. Meaning, what does it mean? It means that you can override, or it means that you can redefine. So you can give your own definition of it, right? Remember, you're still gonna inherit. There's up to you. You can choose to inherit those things, those features. Remember, when you make it overridable, it just means in C++, it's a normal virtual function. That's what it means in C++. It's just a normal virtual function. So overriding is optional. So overriding or redefining is optional, right? It's an option. You don't have to. So when you make it overridable, listen to the terminology or to the English. Overridable. That means you are able to override, meaning you are able to redefine. But the redefinition or overriding is optional. That's what it means when when you just make it a virtual function. Since that's optional, that means the child classes or the derived classes, they can choose whether to override it or not. Then when you make it in a pure virtual function, right? Pure virtual function, it is still overridable, right? But overriding is mandatory. Overriding is now um mandatory tory. So overriding is now mandatory. It's a must that you override. And when you make it pure virtual, in actual sense, what are you doing? It means that the base class does not implement the function. That's what it means when you make it pure virtual. And when the base class does not implement the function, what does it mean? It means that it is a must. The keyword is a must for derived classes to redefine this function, to redefine or override this function. So it's a must when you make it pure virtual. So what's the difference between how do you do it in terms of um, programmatically? How do you write it in code? So to write it in code, you simply say, to write, how to write in code, how to write in code. You simply say virtual to make a virtual function, right? Whatever that function was, you put the virtual keyword before the return type. So let's say virtual to ppm, that was the function, right? And then to make it pure virtual, it's exactly the same thing, right? Exactly the same thing with a subtle difference. The subtle difference that you say is equals to 0. That's the subtle difference. So this would be just a virtual function. And then when you say it's equals to 0, in a way you're saying it is nothing. It's 0. There's no implementation. There's no code. So virtual, pure virtual. pure virtual. So it means that the function has no implementation, there's no code at all. So now you see why you see now the class UJ image will now be incomplete, or whatever that class is will now be incomplete. Why? Because there's missing code. There's a function that does not have code. So now you start to understand, oh, that's why they meant abstract, because there will be a function with no implementation, meaning that within my class I must have a pure virtual function. So this is something that they want you to really think about. Since they want to test if you're doing your practicals too. So yeah, that's why they didn't bother telling you to make it pure virtual. So overrides the splash method to perform the drawing. So you see, they even give you a hint here. You need to override the splash method from the color splasher base class. So that means my splash method needs to be pure virtual. So I need to go put it before the return keyword virtual and then say is equals to 0. So now I've made it pure virtual. So pure virtual. Now it has no code. Well, by no code, it means that when this function, when you go to color splasher the CPP, do not put it there. You said it's incomplete. You didn't. You said that not. You told C++ not to ask for implementation by saying it's equals to 0. So that means the derived classes are forced to override it. So this is an abstract base class. They even told you that it should be abstract. So that's another hint again. It should contain the following: a color record structure representing the color that must be drawn to the onto the image. So we must store that color. So everything they're telling you to do, you must store. And remember, since my class, remember an abstract base class, right? You cannot instantiate it. Why? Because it's incomplete. Can you move into a res whereby there's no doors and there's no showers? It's incomplete. The building is incomplete. Can you move into that res? Nope. Same. The reason why you cannot move into the incomplete building is the same reason you cannot create a color splasher because it's incomplete. So instead of making it private or make it protected, because I know I won't be able to instantiate this color splasher. So I should just make sure that all of my derived classes inherit everything. So I'm going to use the protected keyword. So RGB color. So now you see that you're going to face serious issues here. Remember what I told you okay, it's fine, but in the future, you might not want to include the whole UJ image. Yeah, you might not want to do that. So remember, where's RGB color found? Inside UJ image. So if I say include UJ image header file, what's going to happen? It already contains a class definition. So it's gonna copy and paste this inside color splasher.h. So it's gonna come here and do this. No, it's gonna come here and copy that forward declaration like this. You see, now I'm redefining things. So I cannot include UJ image inside this class, right? Inside this header file. Remember I said header files, you're not meant to include the actual header files of the other classes, right? So you should only do forward declaration. So what I will do is, since this is starting to become complicated, I will cut this UJ struct, right, UJ color, and put it in its own header file. So file, header file, UJ color dot h, so that I include only that thing that I want to include, and then do this, and then define the record structure there, and then there's the record structure. So now inside UJ image, um I'm going to say hash include UJ color.h. Then I go this side, since okay, it's not RGB color, it's UJ color underscore color. It's going to store a color, so I need to tell it where to find that record structure. It's inside UJ color.h. So that we avoid this problem of secular dependence. And then it doesn't know what UJ image is, so I need to do a forward declaration Then this will be forward declaration. And then it should take in a color and then what else? An inner radius for the smallest radius, for representing the smaller radius. So I need to get to store the radius. Remember the radius is of type float double. It's a decimal. So double underscore small or smaller radius, right? So I'll call it smaller radius. Yeah, smaller radius. And then an outer radius, which is the larger radius. So double underscore larger radius. And then they said all the values above must be set via a constructor. So they're telling you to create a parameterized constructor which takes in all these values. So I'm going to create the constructor now. So I'm going to say color splasher, which takes in a UJ color, takes in a double for the smaller radius and another double for the larger radius. And then we're pretty much done with color splasher. Now I can implement the constructor. Remember, the pure virtual function is not supposed to be implemented because that's what you told C++. It's pure virtual. And then we obviously need a destructor, color splasher, and we're going to make it virtual since this is the base class. So it can be overridden or passed to the other classes, the classes that inherit from this class. So remember the pure virtual function, you shouldn't implement it. I'm just putting it here, but then I know very well I'm going to delete. So I'm going to delete it. And then there's my color splasher constructor. They didn't talk about no args constructor, whatever. Do not go too far and put all those, yeah, to put the no args constructor. You can put it if you want, but that's not really going to be marked. So don't bother putting it. And then we have this, and then these are my colors. This will be color, this will be smaller radius. Okay, since now it's going to that side. I'm gonna do this, and then larger radius. And then now I set my color. So my attribute. So underscore color is equals to that color, and then underscore smaller radius is equals to smaller radius, and then underscore larger radius is equals to larger radius. And then that's all you have to do. That's the nice thing about an abstract based class. You don't have to implement much. Okay, so now we need to create a noisy splasher, which is a kind of color splasher. So and then inherit from color splasher. So I'm going to copy noisy splasher here. So you see that our files are going to be quite a lot. And then I'm going to say C++ header noisy splasher.h. And then I save that noise splasher inside my folder. And then I'm going to remove the underscore included. And then I'm going to select all because I want to be able to debug and or release my project. And then now inside the header file, I define the class. So class noisy splasher, right? And then noisy splasher is a kind of color splasher, is a relationship that's inheritance. So it inherits from color splasher. So how do we denote inheritance? You say you put the column there, and then you put the class that you want to inherit from. So let's say color splasher. And by default, if you don't specify how you want to inherit those things, by default, it's going to be inherited or they're going to be made private within the color noisy splasher class. So I want to inherit them. I want to do public inheritance, meaning everything that I inherit here, make it public within my noisy splasher class. Then obviously it needs to know what noisy splasher is, and it needs to know the full class. Remember, with composition or aggregation, you only do for declaration in the header file. With inheritance, it needs the full header file. or the full class. So hash include and then color splasher.h. Why does it need the full class? Well, you cannot do inheritance on an empty class. So if you do for a declaration, it'll be like this incomplete class. What are you inheriting exactly? Because this is an empty class. So hence we need to include the header file. And then we also need to override that method, right? So I'm gonna go back to here and see. So it also takes in extra information, the noise splash. It has a position which is set via the constructor. So it has a position. So that position, I'm assuming it's an integer. They didn't tell us. So I'll make it an unsigned short, and then I'm gonna call it position, right? So there's that position, and then which is set via the constructor. So this is very tricky. You need to understand what you're doing here. So I'm going to create a noise displeasure constructor, right? Which takes in exactly how many parameters. Well, remember, I cannot instantiate color splasher. So these types that I've passed here, I need to also redefine a constructor that takes in that information within the child classes. So I'm going to come here and pass in everything like that. And then I also need to pass in the position because, okay, unsigned short, because this class also takes in a position. So in a way, you're sort of like overriding that class's constructor and passing that extra information that is unique to that class. But then remember, we need to chain it to our base class. And then I need a constructor, so noise destructor, I mean noise splasher. And then I'm going to need the splasher method that was made virtual. There it is here. So I'm going to copy this. And the way you override, right, there's three ways. You can override it like this, right, and just put that keyword virtual to say, okay, this is a virtual, to remind yourself that this was a virtual function. Or you can just omit the virtual keyword entirely. That's the second approach. Then the third approach is to literally say you're overriding, to put the override keyword at the end there, to say I'm overriding that function. Because remember, it was overridable, right? Or pure virtual, or the base class told the child classes to, it's a must for them to override. So hence it overrides it. So I'm just gonna use this third approach. You can choose whatever approach you wanna do. But then remember, keywords like virtual, friend, override, you don't put them inside your CPP files. They only go within the declaration files, which is the header files. So you'll see that when you start implementing. Let me see. So it overrides the splash method to perform the drawing. Yeah, so we're done with noisy splasher. So now I need to create the header file for noisy splasher. So I need to save file and then new file and then CPP file, C++ noisy splasher dot CPP, and then I save the file inside in my folder and then finish. And then now I need to include the header file for noisy splasher. And then now I need to copy my methods. So copy them and then put them here. And then there we go. And then noisy splasher. Okay, and then I'm gonna copy this, put it here. Right, and then my splash method. Remember, the override keyword is not supposed to be in the implementation file. It's only supposed to be in the declaration file, meaning the header file. And then since this will go beyond the screen, I'm just going to format it in this way. So UJ color, I know that this is a color, right? And then this is the smaller radius. So I'll just call it smaller. And then this is the larger radius. So just call it larger. And then the last one is the position. But then remember, I've already have this constructor that initializes this three inside of my base class. So I'm going to chain to my base class. So I'm going to say that's that colon, and then color splasher. And then remember this constructor, as you can see, it's showing me the constructor takes in three parameters, the color and the smaller radius and the larger radius. So I'm going to say color, and then comma. Now it expects a double, which is will be the smaller radius, and then the last double will be the larger radius. So I chain to my base class. So it's going to copy and paste the code inside the constructor, the color splasher constructor, and paste it here, and then substitute and put these values. So remember, this constructor only initializes 3 values. This class also takes in an extra position, so we need to initialize the position. Let's say underscore position. I forgot to put the underscore. So I'm going to say underscore position, initialize it to that position that I'm taking in from the constructor. And then we do not have any dynamically allocated memory or pointers yet, or yeah, there's none here. So I'm just gonna leave it empty. And then we go to solid splasher, which is another kind of color splasher. And we're basically doing the same thing that we did within the noisy splasher. Okay, so the files are quite a lot, so you need to be able to manage all of them. So let's create a solid splasher .h, and then save it within my folder, underscore included, and then all to debug, and then done. And then come here and then create a solid splasher class, which is a kind of a color splasher, but we need to do public inheritance. So I'm going to inherit. So color splasher, but solid splasher needs to know what is color splash. So I need to include the header file. And then I need to create the constructor and the destructor and override the method. So solid splasher is going to have that, and then the destructor. And then I know for sure it's going to have its own private information, right? So an attribute representing the number of circles. So I need to say unsigned short underscore number of circles. And then, like I said, the constructor will take in UJ color, a smaller radius double, and a larger radius double. And it also needs to take in an unsigned short, which represents the number of circles. And then we need to override that function. So remember that function was void splash, which took in a const uj image by reference, but then we need to override it. And then I'm going to say solid splash, and then now I create the CPP file. So C++, and then .cpp, and then there we go, and then all, and then now I need to include its header file. So hash include solid splasher.h, and then now I need to put in my methods. So copy, put in my methods here, right, and then solid splasher colon, then that, and then copy, and then I'm gonna go this side, put in the curly braces, and then remember to remove the override keyword. It's not supposed to be within the implementation file. And then there's my destructor. And then since it's not going to fit on the screen, I'm going to do this like I did in the other class. And then this will be color. So color. Okay, UJ color, and then this will be smaller radius, or just call it smaller, and then larger radius, or just call it larger. And then this is number of circles. And then I need to chain to my color splasher. So color splasher, and then it takes in that color, it takes in the smaller radius, it takes in the larger radius. And this is only the data or the piece of information that it should take in. And then it adds its own information, which is the number of circles. Then we've initialized the number of circles. And then that's pretty much what we have to do so far. So now let me just quickly put in the code for UJ image. So I think that's pretty much all you need inside UJ image. So I'm going to copy all of this, even the friend function. And then so that at least when we continue from UJ image, and we would have implemented a lot of things. Remember, this is not a member function, so I shouldn't say UJ image here. It's not part of UJ image. It's just a friend. And remember, anything that's or a friend, it has access to private attributes, right? Which is like a friend, right? Your friend knows your secrets, right? A trustworthy friend knows your secrets, right? So yeah. So I'm going to do this. And you realize that we're going to need helper methods. So because we have an assignment operator, we are repeating code. So I need to also add those three helper methods. So there's, and then I do not need the constants here. Okay, let me delete the constants. And then that's fine. I'll just leave that comment. Doesn't really make any difference. And then get rows. And then get calls. So there we go. And then get color, and then we have the mutator. Okay, delete a mutator. And then we have our overloaded operators. Some of them, remember the other one is at the top. And then these ones are member functions, right? So I'm gonna specify that they are part of UJ image. And then I have the negation operator, which is also a member function. And then we have the last but not least, the void splash method. And then we have the last thing, which is the destructor. Right, so there's the destructor. Like I said, we need helper methods for this. So let me see the time. Okay, yeah, the time is still good. So I'm going to create helper methods to help. Basically, these helper methods will have the code that'll be there for the constructor. We'll have the code that'll be there for the copy constructor. We'll have the code that'll be there for the destructor because the assignment operator reuses that code or repeats that code. So I'm going to say void constructor. And then when you create these helper methods, you pass in the full parameters. So I'm going to go to the constructor that has the full parameters, which is that one. And then I'm going to put it here. And then I'm going to create another helper method, call it copy constructor, so that I know that the code that it has, it's the code from the copy constructor. So it will take in a const UJ image by reference. And then last one is void destructor, of which I know it's going to take in the code inside of my destructor. Hence, I called it destructor. And then I'm going to put it here at the bottom. And then I'm going to specify that they're part of UJ image class. And then I'll just end the session here. Then we'll continue in the next video. So there's my copy constructor, and then there's my destructor helper method. So we have, remember going to, what is this? Delegate. So I'm going to call the method within color splasher. So it needs to know that color splasher has that method. So therefore, within the CPP file, I need to include the color splasher header file so that it knows where to go and look for that function or for the definition of that function. So yeah, I'll just end it here. We'll continue in the next session.